Hello, today our topic is FFT. What is FFT? FFT means First Fourier Transform. FFT nothing but an effective algorithm of calculation of DFT. In precise, the FFT is an algorithm used to compute the DFT. It makes use the symmetry and periodicity property of Tudor factor to effectively reduce the DFT computation time. Now, before entering the FFT algorithm, we just recall the mathematical definition of DFT. DFT, discrete Fourier transform. Now, definition of DFT. It is a finite duration discrete Fourier sequence which is obtained by sampling one period of frequency transform. Sampling is done at capital N equal to spaced point over the period points over the period extending from omega is equal to 0 to omega is equal to 2 pi. Now, mathematical expression of DFT. The DFT of discrete sequence xn denoted by xk, and it is given by xk is equal to summation of n is equal to 0 to n minus 1 xn e to the power minus j 2 pi by n kn, and k is equal to 0, 1, 2 to capital N minus 1. Since the summation is taken for n point, and that's why it is called n point DFT. And if we take Wn is equal to e to the power minus j 2 pi by n. Now, what is Wn? It is basically Tudor factor. This is called Tudor factor. Tudor factor makes the computation of DFT as a bit easy and fast. Using Tudor factor, we can write equation of DFT as xk is equal to n is equal to 0 to n minus 1 xn wn to the power kn, and again k is equal to 0 to n minus 1. Now, we take an example of DFT. Say we have a time domain sequence like xn is equal to 1, 1, 0, 0. Here the length of the sequence n is equal to 4, and the equation of xk, now we can write n is equal to 0 to summation of 3 as n is equal to 4, so that n minus 1 is equal to 3, and xn w4 capital N replaced by 4 to the power kn, and k starting from 0 to 1, 2, 3. Now, if we calculate this DFT using straightforward implementation method or mathematical definition method, as for k is equal to 0, x0 is equal to n is equal to 0 to 3 xn w4 0 into n is equal to x0 w4 0 into 0 plus x1 w4 0 into 1 plus x2 w4 0 into 2 plus x3 w4 0 into 3, and same as k is equal to 1 for x1 and same for k is equal to 2 x2, and same for k is equal to 3 x3. Now whatever the values of xk, we just notice how many complex addition and complex multiplications are there. For length is equal to 4, the complex multiplication for each xk is equal to 4, and total number of complex multiplication is equal to 4 cross 4 is equal to 16, as the number of point is equal to 4, and complex addition for each xk is equal to 3, and total number of complex addition is equal to 4 cross 3 is equal to 12. If we generalize for length is equal to n, then complex multiplication for each xk is equal to n, and total number of complex multiplication is equal to n square, and complex addition for each xk is equal to n minus 1, and total complex addition is equal to n into n minus 1. Now if we go through matrix multiplication method, in matrix multiplication method we first calculate Tweedle matrix. A Tweedle matrix is calculated according to the Tweedle factors, like W is equal to 1 is for W to the power 0, and the row is changes according to n, and column is changes according to k. And next we calculate xk is equal to Tweedle matrix into time domain discrete sequence. In this way we can easily calculate the DFT of given xn. Now if we notice how many complex multiplication and addition is there, each inner product requires n number complex multiplication. There are n inner products, so hence we require n square multiplication. However, the first row and first column are all ones and should not be counted as multiplication. There are 2n minus 1 such instances. So the number of complex multiplication is n square minus 2n plus 1 or n minus 1 whole square. Each inner product requires n minus 1 complex addition also. There are n inner products, so that we require n into n minus complex addition. So number of complex multiplication n minus 1 square, and number of complex addition n into n minus 1. The operation count, multiplication and addition assume that Wnk has been computed offline and is available in memory. If pre-computed values of Wnk are not available, then operation count will be increases. We will assume that the required Wnk have been pre-computed and are available. For a large number of n minus 1 whole square can be written as n square, and n into n minus 1 also written as n square. So that total number of operation, means addition and multiplication, is equal to 2n square. If we take 256 point DFT, then the total number of operation is about 1 lakhs. It just like 1,31,072. This make this method slow and impractical, even for moderately long sequences also. Now, the first Fourier transform algorithm is used to overcome the above problems. Here, suppose n or number of length is even and we split the sequence into two halves. Each sequence has n by 2 points. Suppose we compute the n by 2 point DFT of each sequence. Multiplication. So total multiplication is equal to 2 into n by 2 whole square is equal to n square by 2. Suppose we are able to combine the individual DFT result to get the originally required DFT. Some computation overhead will be consumed to combine the two results. If n square by 2 plus overhead is less than n square by n square, then this approach will reduce the operation count. Let n is equal to 8. Straightforward implementation or matrix multiplication, it requires approximately 64 multiplications like n square. The first Fourier transform algorithm requires approximately 2 into n 8 by 2 whole square plus overhead, means 32 plus overhead multiplication. And if overhead not very much, then it must be less than 64. FFT algorithm may classified into two types, DIT or decimation in time FFT and DIF, decimation in frequency FFT. In next video, we study about DIT FFT or decimation in time FFT. Thank you.